Hello everyone. Our lesson today it's about lenses. Lenses bend light and form images. Lenses are instruments or are tools that can bend light. When it will bend the light, then it will form an image. There are two main types of lenses. These are the two main types of lenses: convex lens and concave lenses. So, two main types of lenses. Now, let's talk about the first type of lenses, convex. Convex lenses, these lenses are thickest in the middle, as you can see here. In the middle, they are thick and they are thin around the edge or the end of it. Thick in the center, thin at the edge of it. When a parallel, when a ray, a parallel ray, when a parallel lay to the principal axis, it's imaginary line that pass through the center of the lens. When a parallel rays to the principal axis, it passes through a convex lens. What will happen? These rays, it will bend inward. It's now, as you can see here, this it's ray. When it passes through the convex lens, it will bend. It will bend toward where? It will bend toward, or it will bend inward to inside. So, as you can see here, all the rays are bending inward and they are meeting at specific point. This point, they call it principal focus. So, principal focus, it's what? It's the point at which all the rays meet after passing through a convex lens. Again, the point F where they converge or meet is called principal focus. Now, the distance from principal focus from point F to the center of the lens, we call it focal length. The distance from principal focus F to the center of the lens, we call it focal length. This kind of lenses, or the convex lens, is known as a converging lens. Why they call it converging lens? Because it makes the rays or the light rays bend inward and meet at a specific point, meet at principal focus. Rays, it can pass from two sides. Okay, for example, also if the light now if it will pass from this direction, again also the same thing will happen here. The rays, it will bend inward and it will bend inward at F point, which is principal focus, and the same thing, the distance from here it will be to the center, it will be the same as center to the other principal focus. The second kind of lenses, concave lens. Concave lens, or they call them diverging. Diverging, it's opposite to converging. Here the rays, it will bend inward, but here it will be opposite. The light rays, it will spread, it will scatter. Concave lenses, they are thin from the middle, in the middle, and thick at the ends or at the edge of it. When rays parallel to the principal axis, this is the principal axis, we said, when the rays parallel to the principal axis pass through a concave lens, they bend outwards. Okay, they bend outwards. The principal focus, which is F, this point F, from which the rays appear to diverge, spread out. Okay, the principal focus is the point from which the rays appear to diverge or spread out. Here it's the principal focus. Okay, as you can see here, it will start showing that the rays are spreading out. This kind of lens, we call it diverging lens. For the principal focus of concave lens, how we can determine it? Okay. Here, as we say, the rays are parallel. The rays here are parallel to the principal axis. But here, as you can see, once it passes through the lens, it will start spreading out. Okay. Now, if we will draw imaginary line of this light, okay, we will see all the lines will meet at a point. This point, we call it what? We will call it principal focus. Real images formed by a convex lens. Here this diagram, it shows how the image, it will form by using a convex lens. As you can see here, a very distant object from the lens, which is, for example, moon. Moon will send light rays. This light rays, when it will pass through a convex lens, we said convex lens, it will do what? It will bend the rays inward. When this rays, it will bend inward, it will meet at a point. We say, what do you mean by this point, or what do we call this point? We call it principal focus, or it has another name. We call it focal plane. So focal plane or principal focus, it's the same meaning. So this kind of images, we call it real images. Now, how to determine the position of the image that it's formed by a convex lens. Here we have 3 steps. By applying or by doing these three steps, you can determine the position of the image where it will be. Let's take a look on this diagram. Firstly, here what do we have? We have the convex lens. Convex lens object, and we will draw the lines. But how to draw these lines? Firstly, by the way, it's not only 3 lines, okay? You can draw more, but for simplicity, we will use only these 3 lines. And to determine the position of the image, firstly you will need 2 lines, minimum 2 lines, okay? Minimum 2 lines, and maximum more than you can draw more than 2. But how? Firstly, let's take a look here. The steps are: step number 1, you will have a lens, and you will have an object here, this object. Okay. Number one, you will draw, focus on these numbers, how it's written. It's written number one, this it's number two, and then the number three. Okay, you should do it in order. You cannot do number one and then number three and later number two. No, it should be in order. We will see why. The first step, what you will do, you will draw, or number one, you will draw this line, number one. This number line, you will draw a straight line from the top of the object, and it should goes into the center of the lens. It should pass through the center of lens. You will use a ruler, you will draw a line from the top of the object. The line, it must pass through the center point of the lens, and it will pass. Then, okay, number one, a ray through the center passes straight through the lens. Now, number two, which one is number two? This is number two. Why this? Now, as you can see, number two, how it's this line? This line, it's what? It's parallel to this imaginary line. What do we call this imaginary line? We call it principal axis. So step number two, we will draw a line which is parallel to the principal axis. Okay, and then when it will pass through the lens, just bend it inward. Maybe someone will ask, but Mr., why we will bend it like this? Why we will not bend it like this or this? We will see later how this it will affect. Now you finished number one, you finished number two. This is number one, then you will do number two. How to draw number three? A way to draw number three is, now when this number two, it will pass through the principal axis, it will pass through this point. Now, by a ruler, you will use a ruler to measure the distance from this point to the center of the lens. Let's say it's 2 centimeters. What you will do, you will put your ruler here and you will draw another point also after 2 centimeters. So this distance, it should be equal to this distance. You will draw this point here. Okay, now you will draw a line from the top of the object, and this line, it should pass through the F, or should pass through this point, and it goes until the lens, and then from the lens you will put your ruler straight, so it will meet at this point. So this point now, it's what? It's the position of the image. But if you will look at the object and the image, the difference between them, it's what? The arrow, it's to the top, arrow, it's down. What's that mean? The image, it's real, but it's inverted. Inverted, and also it's what? It's smaller. See how much it is? For example, let's say this, if this it's 1 centimeter, here it should be less. Now, what happened here? The object is what? Smaller here. And what else? It's closer to the lens. When the object is smaller and closer to the object, again, what happened? Look at the image. Still the image is real and it's inverted. But what is the difference here? It's enlarged. The image here, it's larger, it's bigger than the object. So I will come back to this question here when I said maybe you will say, Mr. Why we will not draw this line, for example, here or here? If you will change the position of the line, what will happen? The size of the image, it will change. So you can do it. You can change the arrow, but when you will change it, what will happen? The focal principal, the principal focal, sorry, it will change. The position of it, it will change. When it will change, also this one, it will change, and then the size and the position of the image, it will change. Questions. Question number 1. Which of the lenses on the right is a convex lens? A or B? If you will go back to the beginning of lesson, which one is convex? This one. We said convex, it's the one that it's thick from the middle and thin at the edge. So which one is convex? A, it's the convex one. Then, which one is a converging lens? Converging lens. Again, okay. Converging, here is the answer. The convex one, it's the converging one. So, which one is convex? A. Which one is converging? A. Okay. What is meant by principal focus of the convex lens? Principal focus, we just explained it. Okay. So the point F where the converge meet is called principal focus. So principal focus, it's the point at which the rays meet after passing a lens. Okay, so the point F, it's the principal focus. What is meant by the focal length of the convex length? Focal length, again, where is the focal length? Okay, we said it's the distance from the principal focus to the center of the lens. This distance, we call it focal length. Question number 2. A. If a convex lens, this is the convex one, picks up rays from a very distant object, where is the image formed? This example is same as the example of moon, this one. Okay, when this convex lens will pick up rays from a very distant object, where the image will form? The image, it will form at a point where all the inward rays meet, which is, what do we call this point? We call it principal focus. So the image, it will form in the principal focus. If the object is moved toward the lens, what happens to the position and size of the image? If you will come back to here, it says if the object moved toward the lens. Okay, so here, what happened? At the first example, the object, it was farther from the lens. But when the object will be closer to the lens, what will happen to the image of it? What do you think? Okay, you should know now. You should know the answer. Look at these two. You should find the answer. Okay, Here it was far from the lens. The image, it was smaller. But when the object will be closer to the lens, what happened to its image? The image now it's farther, and also it is larger. Question number 3. Question number 3, it says draw a ray diagram like one of those above, the one that we explained, but with the object exactly 2x focal length away from the lens. Draw in and describe the image. Here the main word, or the key answer, the key word for answer here, it's what? It's the object, it's exactly 2x focal length. What's that mean? It means if we will draw, firstly, we will draw the length. Step number 2, we will draw the principal axis. This is the principal axis. It's imaginary line that pass through the center of the lens. Step number 2, we will choose a point that it represents the principal focus. By the way, this point, you can choose it by yourself. It could be here, it could be here, it could be here, it could be in any place. It's up to you. Next step, we will draw another principal focus point. As we know, we said we will have two principal focus points. Okay, how we will know where it's the position of it? The position of it, it's exactly same as the first one. If you will measure the distance from this point to the center of lens, okay, then here it will be the same. Then next step, it's where the object will be. In the question it says the object is exactly 2x focal length. What do you mean by focal length? Focal length is the distance from the principal focus to the center of the lens. For example, let's say if here the distance from this point to the center of the lens, it's, let's say, for example, 1 centimeter. So where the object will be 2x. It means 2 times 1. So it will be 2 centimeters away. So now the red dot, it shows the position of the object. Now we have the object, we have the lens, and we have the principal focus. We have the main points to solve the question. Next step, we will draw a line that shows a ray. As we mentioned before, the rays, it's always parallel to the principal axis. So the orange line, which represents the ray, it should be always parallel to the principal axis, the blue one. By the way, then when you will draw a parallel line, we said when it goes to the lens, it should goes inward. But where inward? It should pass through the F, or which is the principal focus. Now, line shows ray, pass through the principal focus. Now we finish from the first line. Next step, from the red dot, the dot that shows the position of object, to the ray, okay, we will draw the object. Now we found the position and the size of the object. Now the next step, it's what? Now we have the object. Now we need to find the image of it. How we will find the image of it? By drawing another line we will draw another line from the top of the object, and it should pass through the center of the lens. Now, this is the line that it passed from, or the line from the top of the object that passed through the center of the center of the lens. Now, as you can see here, what happened? These two lines, they meet at this point. So the meeting point, okay, now what do we call it? Or it's the point at which the object will be formed. Now, if we will draw the object, we will draw it from here to the point that they will meet. Now we got the image, we have the object and the image of it. The question, it says draw. We finished drawing. Now describe the image. If we want to describe the image, we will say image is real. Why it's real? Because it's formed by the lens. Okay. How it is? It's inverted. All the images that are formed by lenses are inverted. Okay. Now the size. How it's the size? The size, it's what? It's same size as object. If you will now measure the size of object and the size of the image, you will see they will have the same size. And also, it's what? It's 2 times focal length away from the length. Object here, it was, we said it's 2x focal length. Okay, so this, it's 2x focal length. Now also this one, if you will measure the distance from the distance of image from the center, you will see it's 2 times the focal length. Focal length, it's what? The distance from the center of the lens to the principal focus. Dear students, that was everything for this lesson. I hope everything was clear. Again, watch the video, write a comment, and if you have any questions, concerns, please don't hesitate to contact me. Your task for this lesson is to solve the questions on the workbook. Thank you and have a good day.